Okay. So, we've been talking about quadratics, right? And I'm going to just kind of do a little bit of recap because it's been a few minutes or been a little while since we've actually been in here doing notes. We've been practicing factoring for a little while now. So, at the beginning of this chapter, we talked about there being 4 primary skills that we wanted to work on. So there was simplifying, solving, graphing, and modeling. And at this point, we've just kind of been working on the end. That's the skill that we've been spending our time doing. Been talking about the last couple of lessons. I've been talking about the 3 forms of quadratics and how to move in between them. So remember the third form? Yes. Yes. There was intercept form. And there was vertex form. Oops. I wrote the vertex form in the... And I'll pause here for a minute. For those of you that are writing everything down, that was a lot of symbols that got dumped on you all really quick. So we'll pause here for a second, let everybody kind of catch up that's trying to write everything down. But these are all things that have been in the notes already, but it's a nice little summary of kind of where we had been already this chapter. So we've been talking about how to translate back and forth between these 3 forms. So I drew this little picture to help us kind of remember. So to go from intercept to standard form, we FOILed, factor. To go from vertex form to standard form, we did that expand. And then to go from standard form to vertex form, we do this completing the square technique. This is the only one that we haven't talked about how to do yet. So that's what we're going to lead off today. Talking about is using this or doing this completing the square skill. You guys kind of remember this diagram from before, right? Okay. So completing the square is basically the same idea as expanding. It's just kind of in the reverse. Everybody's okay with that? So let's look at an expanding problem, and we'll kind of use that for our model to figure out what we need to do completing the square. Since they're opposite procedures, just like when we developed factoring, we looked at a foiling problem as kind of our motivation for how to figure out how to factor. We'll do the same thing here with an expanding problem to figure out what we mean by completing the square. Okay with that plan? Okay. So here we're going to look at a situation. Oops. So that's the expanding. So let's say that our vertex form polynomial is x plus 3 squared minus 5. So if you guys remember, what expand meant is how to deal with the exponent on the parenthesis here. And we said that x plus 3 squared was really the same thing as x plus 3 times x plus 3. So doing that is what we meant by expanding. And then we can just FOIL this out, right? So x times x is x squared. x times 3 is 3x. 3 times x is 3x. And 3 times 3 is 3 squared. I'm going to write it as 3 squared there for a moment, rather than 9 right away. And I'll explain why as we go about doing it, but it's not a big difference there. Everybody okay doing that? You remember this process? So we can combine some like terms. 3x and 3x is 6x. And then 3 squared minus 5 is 9 minus 5, or 4. Well, let's write one more step. Let's do that. Okay. So now that we've done an expanding problem, we're going to use what we see from the expanding problem and try to work backwards and develop a way to do the completing the square. Since they're going in opposite directions and translating back and forth between standard form and vertex form, stands to reason I can use my work from the expand problem to figure out a way to go backwards. Everybody okay with that idea? Okay. So the weirdest step here is figuring out this one here. How do I move from like x plus 4 to plus 4 to plus 9 minus 5, right? So here's the trick. What we're going to do is we're going to look at this number that doesn't change and see how it's related to this number. So how is 6 related to 9? Well, and then square it, I'll get 9. Everybody agree with that? Why am I dividing it by 2? Because at the previous step, we added 2 things together to make the 6. Everybody agree with that? And notice here at the previous step, the coefficient on those 2 things is the same as whatever we squared to get the 9. So the first thing we're going to take the x coefficient, divide it by 2, and square it. So that gives us 9. Procedure, fairly easy to do. Coming up with it, not trivial, right? You would have had to probably look at that for quite a while to kind of see that, and that's okay. That's why you have a teacher here that's done it before that can tell you exactly what to do it. Now the question here becomes, how do I kind of add 9 and still maintain like equality?
Mr. Kulik?
Yes.
How can we get that first step again?
So the idea is I'm trying to move backwards here. And that's how I'm going to come up with the 9 that's going to go here.
Okay, I see. Thank you.
You're welcome. Okay. So we know that 9 needs to go there, right? But I can't just add a 9 into this polynomial because that's going to change the whole value of the polynomial. What's the only number I could add to this and still have that polynomial stay the same? 0. So the way that I'm going to write down plus 0, I need to involve plus 9. So how do I do that? I write plus 9, and immediately after it I write minus 9. Because 9 minus 9 is still 0. Is everybody okay there? So notice I really haven't done anything. I just added 0, which is nothing at all. Okay? So if I take a look at this piece, 6x plus 9, this is going to factor. What two things multiply to give me 9 and add to give me 6? 3 and 3. And I know x plus 3 times x plus 3 squared, and negative 9 plus 4 is negative 5, and I'm back where I started. So just as a little piece of vocab here, a quadratic like x squared plus 6x plus 9 that factors into two identical pieces like this, we call that kind of quadratic a perfect square. So when we say completing the square, that's what we did when we added 9 and subtracted 9, is we made that perfect square quadratic that we could factor. That's why we call this process completing the square. Because we had part of a perfect square, we just didn't have that last constant value, and that's what we got. So let's do that again. This time without doing the trying to work backwards from an expanding step. Let's just kind of do that straightforward with no sidetrack here. Okay with that plan? Sure. Okay. So x squared minus 10x plus 5. The first thing I do is I'm going to look at that middle number. So 10 divided by 2 squared is 25. Very good with that? So I'm just going to take the polynomial I have, subtract 25 from it, which is doing nothing at all. And then I'm going to factor the new polynomial that I made there. So what two things multiply to give me 25 and add to give me negative 10? Negative 5 and negative 5. It'll always be the same number twice if you've done things correctly. So it has to be that same value. And then negative 25 plus 7 is negative 18. And x minus 5 and x minus 5 I can just write as x minus 5 squared. And we're finished. It's not too bad, right? Could it get worse? Well, yeah. I mean, let's look at an example where it gets a little bit trickier. So 2x squared plus 8x plus 5. How is this problem different than the previous couple we've looked at? Yeah, we have a leading coefficient here of something other than 1, right? Well, it's not quite divide everything by 2 because there's not two sides to do that to, so we can't like divide the whole thing by something. We could if it equaled something else, then we could divide both sides by 2. That would be fine. But here there's no equal sign, so you can't like do something to both sides. But we're going to do something that's like dividing. We're going to take a greatest common factor from the x parts. So that greatest common factor I'm going to take out is a 2. So the idea there is I just want to make that leading coefficient 1 by taking a greatest common factor. Everybody okay to hear? Now I'm going to take the 4, that's the x coefficient, divide it by 2 and square it to get 4. Everybody okay with that? Now the question is I have to add and subtract 4. Where do I put the plus and minus 4 at? Are they going to both go inside the parenthesis, both outside the parenthesis, one in each place? Where should they go? What's up?
One in each place.
Okay. You would think that. The problem is that that's no longer going to be equal because the one inside the parenthesis gets multiplied by 2 and the one outside the parenthesis would not. So you wouldn't have the equivalent of like not doing anything. So they both have to go inside the parenthesis is the answer to that. But it's not a bad idea to think that one would, that they were going to go into one in each place. But we need to do that, both inside the parenthesis. But now we have this extra minus 4 rattling around in there that we don't want. How do we get that minus 4 now out of the parenthesis? This is exactly what you were trying to do here, Hallie, I think. It was you that answered, right?
Yeah.
Okay. Is we're going to distribute the 2, only that negative 4, because everything else we want still left inside that parenthesis, because that's the stuff that we're going to factor. So now I can ask myself, what 2 things multiply to give me 4 and add to give me 4? That's 2 and 2. And then negative 8 plus 5 is negative 3. And x plus 2 times x plus 2 is x plus 2 squared. And there I'm done. So it wasn't that much different than the previous one, right? But there's a little bit of extra to deal with because of that leading coefficient not being 1. But it was still doable, right? Again, the extra steps that we had to do, we had to factor that leading coefficient off as our first step. And then when we add and subtract that number we had to do it both inside the parentheses. And to get the other one that we don't want to factor without, we make sure that we distribute that factor to the one that we don't need. Pick it out of the parentheses. And then we can factor. that okay, guys? Do you want another example, or do we think we're okay? Okay, it's okay, Bianca? Sure. Let's do one more like this, and then we'll move on to the next thing. Okay. So let's say we have 3x squared plus or minus 18x plus 10. First thing I need to do is factor the 3 out from the stuff with the x's on it. So far, so good. Then we're going to take that x coefficient, divide it by 2, and square it. So that's what we're going to add and subtract, and we're going to do that inside the parenthesis. And the piece we don't want is the minus 9. So to kick the minus 9 out of the parenthesis, we just distribute that 3 to it. That boots the negative 9 out. And then we can factor. So multiplies to give me 9 and adds to give me negative 6 is negative 3 and negative 3. And then negative 27 plus 10 is negative 17. And then I can just write x minus 3 times x minus 3 is x minus 3 squared. Okay? Sure. So that kind of wraps up. We've now done all of the simplifying things that we need to do. So we're going to now start solving today. And we're going to look at several different solving scenarios over the next couple of days, because this is a pretty, another pretty long or pretty big topic here, because there's going to be lots of different ways that we can go about doing these solvings depending on the form of our quadratic. So depending on what form our quadratic's written in, we'll use some different solving techniques that we'll develop over the next couple of days. So today, we're going to be talking about solving quadratics that are in intercept form. And to do this, we're going to use a property here called the zero product property. So what the zero product property states is if you have two things that are multiplied together and they equal 0, this is true if and only if at least one of those two things is equal to 0. Which makes sense, right? When you multiply two numbers together, The only way to get 0 is if at least one of them was 0, right? They could both equal 0. 0 times 0 is 0. Or you could have 1 0 and the other could be anything, like 10 or 15 or -6 or 5/3 or whatever. Still times 0 is going to give you 0. But if they were non-zero, there's no way that two non-zero numbers can multiply together and give you not 0, right? That can't happen. So this is a really important property, and we're going to use it a ton here when solving quadratics. So it's very powerful and very useful. So let's look at some examples. So let's say we have x plus 7 times x minus 5 equal to 0. When I look at this, do I have two things multiplying together to equal 0? Yes, right? Each of those parentheses is like one thing. So I can take that entire first parenthesis and set it equal to 0, and set it equal to 0. Now I can solve each of these two problems separately. So if I subtract 7 from both sides, I get x equals -7. If I add 5 to both sides, I get x equals 5. Why am I able to do that? Because it's equal to 0. If that was not equal to 0, I cannot do this. Okay, the equal 0 part is a requirement for this technique. Let's do another. Let's say we have the factored form 2x minus 5 times 3x plus 7 equal to 0. Does the zero product property apply here? Ya betcha! So I can just take each of those two factors and set them each equal to 0 and then solve them separately. So add 5 to both sides and then divide by 2. And then subtract 7 from both sides and then divide by 3. Feel okay here? All right, let's look at another one. So we'll just keep kind of changing a little bit. Little bits here and there. So how many things do I have multiplied together now? Really have 3 things, right? Everybody agree with that? The zero product property still, oh my goodness, equals 0. Zero product property still applies. So I'm just going to take each of those 3 things, solve each one of them as if it was its own separate problem. So how do I solve -3 equal to 0? What the heck does that do? Is that true? Is -3 equal to 0? No, that's a bunch of nonsense, right? So what do I say for that problem? That's no solution, right? There's no x even in there to solve. You have two numbers that are not the same number set equal to each other. That's a bunch of hooey, right? Okay. Well, that's fine. I can ignore that. So then go to the next problem. I can add 5 to both sides. And then that's done. So go to the next one. I can add 1 to both sides. And then divide by 2. So my answers are 5 and 1/2. Everybody okay there? What if we have x squared plus 12x plus 20 equal to 0? Is this an intercept form? No, right? This is standard form. But can we put it into intercept form? Well, maybe, right?
Yes.
What are the two numbers that multiply to give us 20 and add to give us 12? 10 and 2. Now we're in a place where we can apply the zero product property because we have two things. And so now we can attack each of these two things separately. So this is now becoming a pretty versatile method, right? Because factoring we've had a lot of practice at. We're pretty good. If we have something in standard form and we can factor it, it's not too bad. I can get it into a place where I can solve it pretty quickly. Let's do another. What if we squared minus 5x is equal to 14? How is this one different than the previous ones? Okay, doesn't have a C value. What else, though? It doesn't equal 0. And we have to have that in order to use the zero product property, right? So what should be the first thing I do? Let's subtract 14 from both sides, right? It's not currently equal to 0, but we can force it to be equal to 0. That's not hard to do. And now, let's check to see if we can factor. So two numbers that multiply to give me negative 14 and add to give me negative 5 are so negative 7 and positive 2. Yep. And then I can just apply the zero property. So I get x equals 7 and x equals. Feel okay there? So this is starting to look like a pretty versatile solving method, right? What's the catch? Why, Mr. Kuliker, are we going to spend, like you said, several days talking about solving? Like it seems like this is going to work like all the time. Why can't I just do this always? What are two numbers that multiply to give you 1 and add to give you 1? Yeah, there's not two whole numbers that do this, right? So we can't get it into a factored form, so we can't apply the zero product property. So we would need something else to do here, right? That's why this is going to take more than one day, because we have some more methods that have to develop. So this is not factorable. And we'll say by our methods. It is, but we haven't talked about how to do it. So we can't use that zero product property. We need another method. We'll come back to next week when we hit this some more, but I want to plant that seed right now and establish that as great of a method as we develop, because it works wonderfully, it's very fast, it's quite efficient, it makes these problems quite easy, doesn't work for all the problems, which is a big issue. Okay? Let's do some more practice, because not all of our factoring problems are so simple. So what if we have 12x squared minus 8x minus 15 equal to 0? What do you notice that's different about this one than the previous examples? Look at the leading coefficient. It's not 1. What does that mean? Probably can't use our shortcut, right? We should check to see, can we take a 12 out of all of the coefficients? No. Can we take anything out of all the coefficients other than 1? No. So this is a long factoring problem. It's been a while since we've done one of these. Let's kind of do that again and go over how to do that. So we're going to need to find two numbers that multiply to give us the A coefficient, and then add to give us the B coefficient. Now this is a pretty easy pair of numbers to see if you look at it for a second. Does anybody see the pair of numbers that multiply to give us negative 180 and add to give us negative 8? So multiply to give us negative 180 and add to give us negative 8. Emily, do you see it? I thought I saw your hand up for a second. Good. Negative 18 and positive 10. Right? When you say it now, it's like, oh yeah, the 10 makes it easy to find it, right? So what we do with that then is we're going to replace the negative 8x with the negative groups. From the first group, we're going to look for a greatest common factor. What do you see in common between 12x squared and negative 18x? Yes? Okay. There's a bigger number than 3 that divides both of them. There's more than just 6 that divides them. Not a bigger number, but more stuff. About 6x. Everybody okay with that? 12x squared divided by 6x. 12 divided by 6 is 2. X squared divided by negative 18x divided by 6x. 18 divided by 6 is 3. X divided by x is 1. So no more x's. 10x and 15. What do we see there? Greatest common factor is 5. 10x divided by 5 is 2x. 15 divided by 5 is 3. Everybody so far so good? This kind of ringing a bell? I know it's been a minute since we've done one of these. That's part of the reason why I want to make sure we do a couple before we go. Now if I look at this as two separate things, what's in common with each of these things? The 2x minus 3 part. When I factor that off, what's left? 6x plus 5. So now it's factored, right? So I can apply the zero product property now. And I can solve each one of these separately. So if I add 3 to both sides and then divide by 2, by 6, there's our two solutions. What do you guys think? So let's do one more. I'm going to write down the problem and let you guys work on this in your notebook. I'll write down the answer in a few minutes so you can check to see how you did. Okay, so just try to do this one on your own in your notebook. I'll write down the answer here in a minute so you guys can check to see if you got the correct solutions to this solving problem. But this is the last thing that we're going to do today. So this is the last example, the last thing. I put a homework 4 into the content library for you guys to do for the homework check on Sunday. It involves completing the square problems and some of these solving problems like we've done today in class. I think that's the only assignment for you guys this week since we've meet only 2 days and we spent the other day just doing some stuff. But Miss Garcia is going to let me take a break here and I'm going to write down the answer for this one so you guys can, you're finished.
Yes, I'm pointing at the sign behind that. Not you, but the double airplane. So this is what you're doing instead of taking notes?
No, I was taking notes. This one, I looked it up. This one's going to spin, so it's like,
Yeah, prove it.
let's see it.
Woo! Oh, nice job.
I don't know what this one's going to do.
I have to say, I am quite impressed.
Let's see the kamikaze. Oh, shit. I mean,
That was kind of cool.
that one was okay.
And I have to say, I am quite impressed. I hope the scales are as good as your
If you put a bunch of chimpanzees in a room,
paper airplane making ability. I think that you need to start a contest at lunch as to who can make the best paper airplanes. That's what you need to do.
Dude, this one.
Because you guys are way too bored at lunch. You need something to entertain your brain.
Wait,
Let's throw that one.
Almost killed
Yeah, this one goes up and then goes.
Dude!
Oh, yeah. No, let it go.
Oh, that's
It
okay.
stays in the air for a long time. This one goes up.
All the ones you throw in the whole thing. We gotta touch the loop one again.
The rips in this just make it stay in the air.
Evan.
Okay, I think Bianca feels like she's under attack now.
She is. Airstrike!
It's
I'm so... Dude, everyone keeps in here. Hang on, let's try this one again. Oh!
I have it, that was fine.
It does one loop and.
Oh, side arm. I'm in side arm.
There's somebody here for Jack. I know. Oh, I think it's this one.
No,
Oh, it's like a square one.
this one is so nice.
That one's crispy, bro. Ow! Jesus Christ. You did not.
Wait,
What is this one? Jack,
This one's mine.
that one's the silky one.
this is the best one, man.
That one has both.
Oh, yeah. Oh, yeah. Oh, yeah. Oh, my goodness.
Okay, you need to calm down a little bit.
Alright, I'm on.
Okay. Look at this one I made. That one's not that good.
This one's not in your packet.
Let's see that. That one's got a hefty up.
What is that?
You threw it too hard.
What? Two of those going in.
Look at this one, Jack.
It's not trash. This side one.
I just did some.
Jack, come here. Look at the one I'm gonna make next time.
Yeah, hit one really cool with this. Oh my god.
Jack, come here. I'm gonna make this one. Guys, I'll make this next
Bye,
time.
everybody.
I'll take the whole class. Here, don't look at that one.
This one, bro. You know if they flip or spin around, they gotta do this.
Either that, Jack, either that one or this one. Yeah, hold on a little bit. We're getting too many airbags.
Oh, I'm sorry.
Ooh. Who wants the loop one?
Dude, we were like,
Hey, Jack, keep doing this. You'll stop giving us some of those.
this one is so nice, bro.
I'm branding this one.
This one's not working.
This is great.
You just brave it too. Yeah, you do. I don't know why you're so bad. I'm gonna make it adjust. Look at that.
Bro, it's so silky.
I got one under here.
That's
Silky.
silky.
You're silky, you're smooth. What is it? Crispy and silky. Crispy and silky.
Alright, now, I'm gonna go from this end to that. In the trash.
Yeah, hit some.
Bravo.
Oh.
Go!
Oh.
Not again, not actually good.
That one's got it.
I'll give it back to you, man.
Okay.
What a guy. It's not in the
Try to land it up there. Evan.
Okay, that was actually the best
Ah,
one.
you're right.
Gotta get him.
Oh, too much power.
Alright, just made some adjustments with this
What
one.
to learn better?
To see it better.
It's fine.
Why is he throwing it?
Jack, I was like,
We gotta take these
Oh, I
outside.
think
Just
you-
let- We gotta let the wind
Dude, this one's a boomerang. Brady, this one's going
I know, but I don't know why it keeps curving back.
I kinda like it.
Yo.
Hey, throw it and try to catch it.
Jack.
Yeah,
Bro,
yeah.
John.
Jack, give me the whole end.
That one went like.
It's a butterfly.
Yeah.
The butterfly.
Dude, just a lip, bro.
Okay, wait, throw it this way and I'll try to catch it. Jack, no, throw it this way, throw it this way.
Oh, shoot.
Dude, that one did the same. It did a full like circle. Okay. Who made this one?
Alright,
This
so I'm
one.
gonna throw it in a loop, so go like
Okay.
Yeah, we go right here.
Then I'll throw it this way.
That one doesn't work very well.
Wait, just like this? You do it?
Throw it at, just throw it. You do is throw it.
Yeah, you
Oh.
know, take it off.
Hey, throw it this way, Pat. Throw it this way. Go this way.
Yeah. Well, we put the flaps down.
Yeah, that one's pretty bad. Though. Dude, we're like 4-0. Nah,
I
it's
that
bad.
one. Okay, you got that. Okay, I'm gonna make
This one looks.
What is that one?
Wouldn't go anywhere.
I made this one. I'm sorry.
Nice.
Oh! I made this one, but I cut it.
You know where it is.
It's right here.
But I put them down. So.
It's right here.
Let's see what happens.
Close this one.
Where's the good one? Where's the good one?
Go ahead.
Oh, dude, I don't know why.
Tristan, ready? Okay, I have this community time next week, so making these up a little bit.
Oh, well.
You was like 2 keep that. Alright, let's pick it up a little bit.
Okay, gentlemen, I think we're all done with that.
Alright,
One last one, I make sure
last
that
one.
trash can.
Oh, get the throw it this way.
I got that
This way.
trash can.
Throw it in this direction.
There's so many.
You missed. Sit down. You
Get
missed
the
a lot.
Gucci bag.
Okay.
Please take a foot.
This is gonna, I'm
I
gonna
know,
roll
he
it,
said we were all done.
and it's gonna land on that
all
trash
in
can.
time. Go
Look,
slow.
Jack, I named
I'm
it.
very impressed with your playing skills. All done.
Boys,
Gentlemen, park your butts in a chair. Let's go. We're all done. You had fun. Do it at lunch now. All done.
Dude, Ola.
I'm keeping this one.
Ola. Giants interested in college. I should train them.
Make me use my knee.
That would be terrible.
That'd be so fun.
He would just be.
Just like Golden Tate. It's like Golden Tate Part 2. Golden Tate Part 2.
I met Golden Tate once.
Yeah.
Nice guy. Hey, what you did? I feel like a like 70 stack, I think.
Good use.
That's really lovely. I'm sure that you will get a girl with one of your voice.
Oh!
Yeah, I'll be the analyst. Head goes down a little bit.
Right, you're trying.
No, yours are okay. Now you gotta do is do a song.
Control.
Come on, make that.
Wait, hold on, John.
Oh, it's in mine.
Let's try to evacuate the premises.
Pardon me?
Can you evacuate the premises?
So, like,
The time?
yeah, it is.
I guess so.
I swear. Yeah, someone.
That one's garbage, so. Yeah.
This kid jumps up her wall, puts a shirt in my face, and I get called for a foul. What? Or just something I wrote on my feet. I said, yeah. What happened?
Over 20? Is that a little bit better?